along. Our next presentation is from Emma Rott. She is an environmental engineer for CDM Smith in Helena, Montana. She studied environmental engineering at Montana Tech in Butte, Montana, and has been roaming around abandoned mine land for work and fun ever since. Thank you. All right, so today I'm going to be talking about characterizing metal loading from historical tailings impoundment to alluvial groundwater and surface water at the Bonita Peak Superfund site. You guys have been sitting in on a lot of these Hardrock sessions. You've probably already heard a lot about the Bonita Peak Superfund site, but just going to keep pounding the history into your brain so we all leave this conference a really good understanding of what has happened at the site before. So the Bonita Peak Superfund site is located just south of where we are in the San Juan Mountains of Colorado. It's made up of 48 historical mines or mining-related sources that have been identified, but again, is a historical mining district, so lots more out there. It consists of three major drainages. There's Mineral Creek, Cement Creek, and the Upper Animas River, which is what I'm going to be focusing on today. And like all old hard rock mining sites, the major contaminants include heavy metals, so aluminum, arsenic, cadmium, copper, lead, manganese, and zinc. The site is broken up into 5 operable units, and CDM Smith was tasked with the remedial investigation for operable unit 1, which is the site-wide remedial investigation. And there's multiple priority reaches within those operable units, and so priority reach number 2 on the Upper Animas River is the site that I'll be looking at specifically. And then within priority reach number 2, there's multiple different mines, old tailings piles, old mills, and a lot of just non-point source alluvial tailings that are contributing to pretty large loads of metals going into the Upper Animas. And one of those is the Howardsville tailings site. And a lot of old documentation, it's also known as the Pride of the West mill, which was originally built in 1940. And that mill was actively permitted from 1984 through 2017, where it was processing lead, ore for lead, zinc, and silver. And so if we're looking at this site, yeah, this is the most recent aerial image that we have. So down here, you can kind of see this is some of the mill buildings that still exist and some of the more recent ones. And then we've got 2 major tailings piles, the upper tailings pond, the lower tailings pile. This area is what we've known as the alluvial tailings area. And then this area too, which will come into play in the later part of the presentation, is what we call the former tailings pond area. So part of our remedial investigation, one of the first steps that we take is doing a really big desktop review to try and gather together all of the information that's been documented about this site before. As we all know, Bonita Peak has been studied for a very long time, but there wasn't always great documentation as to what was done at sites such as Howardsville. So some of the things we were able to find were these historical aerial images that really gave us a good idea of what the site has looked like over time. So on the left here, we have an image from 1951, where it appears we just have one tailings pile here and some mill buildings here. And by 1987, that original tailings pile looks like it's still there, but in the addition to 2 more tailings piles that characteristically look a lot like the tailings piles that we see flashing back here in modern day. Again, with our desktop review, we tried to gather in information of any previous reclamation or remediation that has been done at the site to date. Again, not a lot of great documentation to fully understand what all happened, but what we could find was in 1997, there was a pretty large removal. About 84,000 cubic yards of mill tailings were removed from the tailings impoundments and dispersed elsewhere along the site. In 2003, because it was still an actively permitted mill, additional mine waste from the district was milled at the site and then disposed of in those tailings impoundments. And then in 2016, after the permit for the mill was revoked, some of that bond money was used for some remediation activities within the site. And in 2017, one of those tailings ponds had an emergency dewatering project. And most recently, in 2021, there was an emergency response in these mill buildings here. It seemed as though when the owners left, they closed up shop and didn't really think much of what they were leaving behind. But when an investigation into those mill buildings started, there's numerous drums of various chemicals and bags, definitely not labeled well. Some were labeled well, but those that were labeled well were also not in great condition. So it's a pretty big hazard that EPA was able to go in and clean up entirely. And I believe that was finished in 2021. So a couple of the previous investigations that have been specific to Howardsville tailings, so the site as a whole has been investigated for a long time, like I previously said. But a lot of these investigations were more on a watershed level overview, not specific to this Howardsville tailings, for example. And along these reaches, especially in the upper Animus, there's a lot of these non-point sources. So it's pretty easy on a mine site if you've got a draining adit with bright orange water pouring out to say, oh, that's our load coming into the river. But for non-point sources, it's a lot more difficult to characterize, and Howardsville tailings is one of those in particular. There's been a lot of surface water sampling conducted by CDMG and USGS over the years, but again, that's pretty high level. There'd be miles in between each sampling point along the reach. In 2016, there was a general site reconnaissance that CDM Smith and EPA conducted to get a better idea before the beginning of the remedial investigation to understand just current site conditions. Because like I said, there's been a lot of changes over the years at these sites and it hasn't been well documented. So before we really dove into everything, we wanted to get an idea of what it actually looked like. And then in 2017, it was evaluated as a possible location for a repository for the Superfund site as a whole. And during that investigation, they installed multiple monitoring wells, one of which you can see here with the Little Nation Mill in the background, which is a historical mill in the area that was constructed in the early 1900s. So with gathering all of our previous investigation work and all of the sampling data that has previously been collected, we were able to come together with a bunch of data gaps that we found in order to figure out where the metal loading from this was coming together. So in 2021, we were able to start our actual field effort of the remedial investigation. And with the data that we had seen, it's obvious that there was definitely significant metal loading in the upper Animus reach of the river within this Howardsville reach. But where it was coming from was not exactly clear. And the tailings impoundments that we could see on the aerial images, again, we've got a pretty decent idea of the lateral and vertical extent of those, but the interaction of alluvial groundwater with those tailings was not really well understood at all at the site. And here's just an image too of one of the tailings ponds as you're looking south towards the mill building. So with that in mind, we conducted a field investigation in September and October of 2021, where me and a couple of my colleagues were able to spend a couple months down there watching all the aspens change and doing a bunch of work in the Howardsville area. And that included test pit excavations, additional monitoring well installation, groundwater sampling, surface water sampling, and pore water sampling. We can look specifically here, so it's kind of maybe a little hard to see, but for our investigation, we excavated test pits up here in the fluvial tailings area, and we would excavate down just to shallow groundwater where we'd then collect collect that water sample once we reached it, or if we reached it, and then additional soil samples along the way. And then we installed quite a few wells within the tailings impoundments themselves. I'm going to call out specifically the wells that we installed along this tailings impoundment berm. And then also, we had installed one well here, attempted to install multiple other wells here, but unfortunately it's pretty boggy, as you can kind of tell in the aerial photo, so our drillers were not quite pleased with having to go all the way out there. So instead, we hand installed a piezometer down here, again, to try and understand the interaction of the alluvial groundwater with the tailings here on site. Our surface water and pore water sample locations, we primarily aimed for sticking to the main fork of the Animus River that moves from that corner up down to this corner from northeast, to the southwest. but we were also able to collect paired pore water surface water samples in these ponds just to the west of that tailings impoundment there. And in previous investigations that had occurred, some of these surface water sample locations that they collected were from here to here, all the way down to here. So there was a pretty big gap from the historical data that we had seen from in this area, which becomes pretty important based off of the results that we found. So with the results that we got from all of this investigation, we plugged a lot of this information into Leapfrog to create a 3D conceptual site model. And some of that came from our soil sample results, both from the monitoring wells and the test pits that we excavated. And so, you can see pretty high levels of lead, manganese, and zincs and other metals as well. Our test pit excavations, we saw definitely the highest levels in areas where there was visible tailings on the surface. And we weren't necessarily targeting those areas for excavating right there, but there's in that alluvial tailings area where tailings no longer exist, it's pretty obvious that they're scattered everywhere, and that's where we saw the highest results. For our soil borings, we augered in both into the actual tailings impoundments and then also along that berm and closer to those mill buildings as well. And we found the maximum concentrations to be along the berm of that tailings impoundments. There's high concentrations within the tailings too, of course, but we were a little surprised to find it a little outside of the actual tailings. Once we installed the monitoring wells, we collected groundwater elevations and created a potentiometric surface map to better understand, again, how the groundwater is interacting and where it's flowing to. As we suspected, the groundwater elevations generally decreased from up valley to down valley, similar with the surface elevation. It was generally moving across the tailings ponds here towards the current tailings impoundments towards the tailings ponds. And then what we saw down here was that definitely this groundwater was directing right towards the upper animus. Now to take a look at our first look at the 3D model that we were able to pull together. So not a great, I guess you can't really see well where the historical or where the different tailings impoundments are, but this line right here is that berm in between the tailings impoundments and those tailings ponds. So as you can see, there's some pretty screaming hot levels of zinc found in those monitoring wells. And we did screen these wells within the tailings because we were targeting at this time, looking at just water within the tailings and seeing how it's interacting and whether or not it's coming towards surface water. So right through there, yeah, these two wells had ridiculously high levels of zinc in them, and we were able to pull in information from our soil borings, our surface water and pore water data too, to pull this together. And looking at the cross-sectional view of it, so up here is the actual tailings impoundments, and we did install a couple of wells in the tailings impoundments in 2021 that punched below the tailings, where we found relatively clean-ish water. So it was pretty evident to us that at least within this area, not a lot of that contamination was moving further, or that there was a pretty good confining layer in between those two. And then right here, this is the berm in between the tailings impoundments and those former tailings ponds, where we saw those really high levels of zinc. And then coming into here, this is the tailings ponds and that marshy area that the water flow is moving directly towards the Animas River, which is located right here. So utilizing our 3D model, we looked back at some of those historical aerial images of the site. And lo and behold, our hot spot is pretty darn similar to the 1951 extensive tailings that were excavated at one point and removed, but it appears as though the excavation didn't quite do the job it was intended to do. So this is all preliminary data just from these wells that we installed last year, but this was a really good tool for us to see, how the site has shifted over time and what we're still seeing today with the contamination. Now, when we looked at the surface water and pore water results, again, to kind of answer our question as to where is this load, metal load coming in throughout that reach, to give you a sense of the data that we looked at before this investigation. So a lot of the data points we had were from this point to this point. So if you were to take out everything in the between, you'd have a pretty straight line that would seem like you're getting a pretty consistent load across the reach. But with our investigation, we included additional sampling points along this reach to give us a better resolution. And clearly, towards the end of the reach, once you get past the main tailings area, these concentrations started to pick up pretty drastically. And in fact, 2 of the seeps that are coming directly from those former tailings pond area aren't even shown on this graph because their concentrations were orders of magnitude above all of these other sampling point locations. CGO1 and O2, which I can flash back to the map, had concentrations of 9,400 and 11,000 micrograms per liter of zinc. And then when we pulled together our loading map, this was really a moment for us all where we were like, oh my gosh, our chart is telling us the story exactly of what we thought, and telling us pretty loud and clearly too. So the CGO1 and 2 that I was just talking about, here are those 2 points. And you can see towards the end of the Howardsville Reach, it picks up quite a bit, about 2.2 CFS through here. And this is upstream of Cunningham Gulch, so it's not another creek or anything coming in to it. It's just the influent from those tailings ponds downstream. And these 2 points right here, so this load increase, pretty big from these 2 sampling points, but definitely don't account for the load from here to here. It accounts for about 1/3 of that load. So the other 2/3 of that load are not accounted for in surface water and pore water. So ding, 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 our alluvial groundwater is clearly coming into the upper Animus through this reach right here in the conceptual site model that you can see where, a lot of the surface water, pore water data did not fully account for it. So therefore, the only other factor is the alluvial groundwater. So of course, there's a lot of work to be continued here, like all sites. They were down there in September of this year completing additional field work, and that included the installation of additional wells, a lot of those being deeper monitoring wells paired with the shallow ones to try and understand if there is more vertical movement of the plume throughout this area. And then they also conducted hydraulic conductivity testing or slug testing to get a better understanding of how quickly the groundwater is moving through this area. And then at this site too, it's important to continue monitoring to assess any seasonal variations to see if those loads change throughout the seasons, or see if the groundwater movement changes too. And then eventually, hopefully, putting this all together in a remedial investigation report to get the site moved on and get it cleaned up. So are there any questions?